Thank you. Thank you for the introduction. It's a pleasure to be today here with you. And thank you to Materialise to give Atos this opportunity. I would like to share with you today a bit about Atos. Atos is not really well known in additive manufacturing. And as well, I would like to share the view of this digital transformation plus engineering transformation that we can talk. Just then go into the deep technical side, we will share this new development of an insert that we developed together, Materialise and Atos. Then Atos, as you can see, Atos is a big company. Atos has been working during the last years through different, growing acquisitions to be the first European in cloud, in big data, cybersecurity, and high-performance compute. Within Atos, we have an engineering services department. It's where I come from. And this department, this area, has been the incubator for additive manufacturing within Atos. We started with some research development program in 2012, managing to give and to deliver additive manufacturing services in 2014. And just since last year, being with this partnership with Materialise, we can even create these pieces for the aerospace sector. We are used to work on the aerospace, but also as well on train automotive or oil sector. Then we work, our typical mechanical engineering topics are about methods, materials, CAD design. Then we have made a change on our team, a training on our team to make them not only know the traditional way of designing, but as well to know all these different topics for AM. These are just some examples of our expertise during these years. We have been working on this repair project about predictive maintenance on planes. Can you imagine just you have some sensor that says that a crack is growing in an aircraft, and then when the aircraft arrives to the next airport, the piece is already ready to be assembled. Then you can reduce a lot of times. We have also worked about this ALM process simulation, the temperature, distortions, and so on. We even won a prize on a design challenge in order just to cope with, all these new designs, customization designs, and integrating different products. We have already designed brackets in titanium ready to fly. And as well, we've been working a lot on augmented reality and connected with 3D printers for maintenance, scanning and then printing. And the last project we will see is this digital manufacturing platform that it connects these two worlds. About parametric lattice structures, there's a lot to talk about that, and we will see something there, but it's interesting to see how many different lattice structures you can build, and what are the properties, and how the software design and stress software are not really ready to use them on a piece. Then, if we go, then Atos speaks these two languages, this engineering, knowing the product design, and as well integrating through this new generation of technological platforms all the digital services. We are talking about security, distributed manufacturing, cloud, Internet of Things, and big data. We are going to go through it. Then why we say that this is connected? We have the engineering services as well with our partnership with Materialise that make it possible to introduce all these new requirements and manufacturing requirements into the pieces. And then we have these platforms, where we need a business analysis and integration of all these software and systems. Then if you know the product, it's much easier, to define the right platform to follow up all the process of the product, as well for the PLM and software optimization. We can as well integrate all these digital solutions. For example, for this distributed manufacturing, we need this security, cybersecurity and IP protection stuff just to be implemented into the platforms, and as well maybe with some cloud solution, private or public cloud solution. But we can also, for example, work on the manufacturing process control with big data analytics integrated with Internet of Things, and as well into a PLM solution and MES, where the parameters to control the process are defined. There's some solutions that, for example, this MindSphere platform is a co-investment with Siemens that cope with that connect all this together. Atos Codex is the solution for big data analytics. And as well, if you know the product, you can interpret it and the results of those. Then we are talking a lot about security. Here we are talking about this digital world, and we need to secure the information. We are talking about intellectual property, about IT infrastructure security and privacy on all the medical sector is really important, but as well as digital rights management. We will need to control how many times a user is allowed to print some model. And we will never transfer the model, we just will transfer the information for that. This is very important just to the next step. And that's why we've been working on this proof of digital platform. This consists on, is a prototype, and it consists on creating some virtual library parts, and even to create a design office that can adapt easily the design. And then you define some users with roles and permissions. Then to access this PLM manufacturing pool where you have all the designs, you need those permissions, and then you can send it, modify it if you need it, and send it to the printer. And in the printer, again, we find another locker. It's again about authorization of printing, and IP protection on the way of just getting the object itself. Then we have just deployed all these platforms through the different Atos sites on the different printers that Atos has on each site. And it's already working. Then how is this for the user? The user just has to go there. For example, if you need a repair, just select the part and just customize it in case you need to customize or the part allows to do it. And then just send it for authorizations. Once you get the authorization, you can print the part, always with this blockchain technology that allows this security. Okay, then also changes affect to the way that we do engineering. We need, I mean, the cycle is not anymore this linear cycle. We need cycle itself with optimization and design. And as well, the tools need to transform in the same way. Then, I mean, we see that digital solution as well as business solution, I mean, with all the main players are needed to go on. We need to go together to go for additive manufacturing. And that's why we can see, now we're going to see an example. In this case, we work with Materialise on all this definition of this new product. Okay, this is we are going to see that the first step was the identification of the product. We select a product that is part of the. We select the product just for mass production in this case. Okay, we're going to see the product because I think it's more graphical. This is a satellite. It's one of the big satellites. Okay, can even weigh like 6 tons, and then the thing is that the satellite is ready just to be attached on the lower part for the launcher, and then you can support, I mean, it can support all the vibrations and so on just to be launched. But there's one time that you have to take the satellite from the upper part and put it inside the launcher, okay? Then it's heavy, and then to transfer those loads, the traditional way of doing it is this hot bonded insert. That means that on a sandwich panel, really light panel done with carbon fiber skins and aluminum honeycomb, you have to introduce a really heavy element, titanium in this case, to reduce the difference between the coefficients of expansion of the two materials. But you just need this insert because you need this bonding area. Okay? It's just the bonded area with the skin, the one that is sizing this block. Okay? And these 4 holes that we can see are where are screws or the hoisting, okay? All the lifting mechanisms, the slings. Okay? Mechanical loads are quite high, and even we need to cover those cases of failure of one of the slings and things like that. Then it becomes a really sizing area. Okay, then in this case, if we only need the 2 faces and the screw part, why not to make it empty? Then it was a nice case for additive manufacturing. Then we run the first topological optimization in order to find the best solution still with the right stiffness, but less mass. This 70% mass reduction is just found by mathematical optimization, but no design constraints or no manufacturing constraints are still implemented. Then we check what's going on with this. In this case, we have seen that thermoelastic stresses are very important for this sizing because we don't want any issue during the curing process where the material is going up to 180 degrees and the different coefficient of expansion can make problems during the manufacturing. Then we just simulate the situation before and after, and we can see that as it's less stiffer, it's better. But we can see still some peaks there, okay, that we want to avoid. Why not to do some more optimization? Then we went to safe optimization in order to find the way of reducing more and more all these peaks. And we find that the butterfly shape is really nice in terms of this stress distribution. Okay, then now let's go for manufacturing constraints. We need to decide how to orient the part, how to see the overhangs, if we need supports or not, and even to prevent the power removal and so on. Okay, then when we implement all these limitations and constraints, in this case, we decided to print it on this position, vertical position that we can find there, in order to avoid any supports. But this makes us to change a bit the design because we cannot have this flat surface, this cluster surface. Then we make this angle 45 degrees because then it was possible just to make it without any support because if not, the support should be on the inside. But this deals another thing is that the external part needs to connect with the core with the core of the sandwich, and we usually use a foam over there. Then for the connection with the foam, we had to put those bars in order to have a better connectivity there. And as well, we were a bit scared about the distortions while manufacturing these 2 vertical walls for bonding. And for bonding, we need really a nice flatness and nice finish of the surface. And that's why we decided just to add thickness and add a milling operation afterwards. Okay. Okay. This is one of the designs, but what about if we try to put some structure inside in order to avoid this over thickness and in order to avoid the milling operation afterwards? Let's try. And in this case, we were just optimizing and trying to find the right lattice. Is a compromise between minimum mass that we want, but if you put the lattice inside, it's going to get a load, and it could fail. Then we need to be on the safe way. We don't want things to fail there inside. As well, all these points where the crosses is where we have the critical points, concentration points for stresses. Then we want a minimum radius for mass, but we don't want to fail there, okay? Then the right radius was selected. And what allows this? We need to fill it up with this lattice. We can avoid then having over thickness, and we can even design it with less thickness than before. That's why is this mass reduction. Then we derive these two configurations. For configuration number, well, we need to check before all the full justification under all mechanical loads, okay? Both of them were right, and the stress distribution on the panel was also nice. And then we manufacture it, and it's the piece that you can find there. It was great that it was manufactured in the first shot, no issues there. And I think it's just because we took into account all the manufacturing constraints before closing the design. And we have already done the first dimensional verifications and so, and it's all in line with the expected one. And you can see here how the initial weight was 1.5 kilos, and now we are talking about 0.5 kilo. And a satellite has 8 of those, and 1 kilo on the space is really expensive. Now what's next? This insert is now in the testing campaign. Now we are going to test it dynamically and statically as being the same place. Okay, and just to say that as we've been all talking around all this day, we need to look for partnerships, and co-creation, co-investment is a must.